Alright, so note in the beginning of this video, so the origin's here, the car should start somewhere around here. So I'm going to set the car there. It's moving forward slightly, but see how it's jittering back and forth a bit, which is bad, and it's going to jump to the right. That's not what I want to see happening. See how it just went backwards? That's not good, because it might mess up my waypoints when it's going forward. It should always be increasing for the most part. I could probably manually edit the waypoints.csv for now. But it does make me a little scared because I would have liked the car to just move forward. Perhaps it's just not a good starting point. But even then, if there are parts here where the car moves backwards, it should be able to figure it out itself. So I may just edit the initial points so that the x-axis is always increasing. I'll just remove the ones where x-axis decreases. And I think that should make it okay. I like this starting point and I don't want to change it because this is right outside the MLab door. So it's just simple to start. Although realistically, you probably don't want to start in front of a lab door because there's a lot of people walking in and out. I just realized, this whole map was, by the way, made with like Photoshop. I just took this floor plan and implemented inside here using some pixel to meter conversion. So every pixel is equal to 0.05 meters. Now, I actually localized very well now compared to what I had before. Even down here, look how smooth these walls are, and yet it knows it's moving forward. I think it's because of the viscodometry. Because I don't see how it can match anything here, especially when you can't see that far ahead. And it's about to end just now. Let me quit this, and then quit the bag file. Now, basically what I'll do is I'll go into the home directory and look at my waypoints.csv. So obviously these ones are baloney because this was the initialized point beforehand. And then the endpoints, I also don't want it to loop together, so I'm also going to delete some of them. It's odd because the x-axis momentarily gets smaller here and then gets bigger again. But let's end it at about like maybe -2 or so, just so we really have enough space. Look how many waypoints I have because I drove it slowly. I mean, that's pretty good. Whoops. Like 2,000 waypoints or so is actually a lot. So we'll see how it does computationally. I'm really curious about is these top points. So up here we have what, like, starts at 1.9, goes to 2. It'll probably get smaller at some point, which is bad because in the real world it's gonna tell the robot to go backwards or have a really big steering angle. Alright, so see how it drops here to 3.25 and then drops back down again. You know, I might just try this first just to see how it does. It's a good learning exercise, see what happens. I think it might be okay because the car might be fast enough to get to the next point before it really gets impacted. Because when I'm scrolling through, they generally look like they're increasing. And as long as the car, I mean, I'm limiting at 30 degrees, so the worst comes to worst for like a split second, it'll make 30 degrees bigger. It should get up to, yeah, that's about right. It's doing a loop. So essentially, let me just continue the video to show you what happens. So I have this waypoints.csv. I'm going to Control-C it. I'm going to bring this into my pure pursuit algorithm and copy and paste it here. Before I had something called Levine waypoints. I'm going to call this Levine waypoints with like narrow turns. I don't want to delete back these waypoint files because they don't take too long to make, but it's just nice to have them. So this is going to be called Levine waypoints. Whoops. So we have this file, and essentially when I bring this out in the hall, all I have to do is run this ROS launch pure pursuit.launch. So if you want to see, I'll actually bring this out right now to show you. Actually, I can't because I need my iPad, so never mind.